In this session, we're going to see how we can improve the security of our application thanks of Istio. Okay, just so you know, all of the session is it's been recorded, so you can watch it later, I think. So, but in any case, I've got two links for you. One is the end.dev/Istio tutorial. This is all my demo is there with with the HTML page and the source codes and so on. So you can replay on your own at home, maybe later, maybe tomorrow. And then also the end.dev/Istio master. That's the slides. So my name is Alex Soto, and yeah, I'm director of developer experience of Red Hat, and my Twitter is Alex Soto V. If you want to stay updated with news about Kubernetes, Istio, Knative, or even Java, you can follow me. Of course, if you've got any question after the session, you can also use Twitter, and I will be really happy to answer them. And if not, if you want to do it more privately, you can also send me an email, sotowe@redhat.com. So let's start. First of all, let me explain to you that when you are into the microservices architecture, and usually we've got our service, my service that can be written in Go, in Java, in JavaScript, Spring Boot, Vertex, Quarkus, or wherever, right? And then we've got what we call microservices. These are some of cross-cutting concerns. I like to call it cross-cutting concerns in the sense that because we are into a microservice architecture, we need to implement. We need to define an API. We need to find a way to discover services, to invoke services, the elasticity, the resiliency, what's happening when one of our services are failing. The pipeline, we need to be able to deploy our services independently. Authentication, how we deal with the authentication between services. Logging, monitoring, and tracing. So usually what we end up when we are into the microservice architecture is having something like this. We've got, in case of Java, we've got the container, then we've got the Java virtual machine, and then we've got the service A, or service, or business logic. And then we've got all these cross-cutting concern, all these microservices features implemented inside the service, maybe in form of a library. Probably if you are into the Java world, you are using Istio or Resilient4j for resiliency, or maybe you're using the Jigger for the Jigger API for tracing, and the same for metrics, and the same for load balancer. And we are just replicating all this stuff in all the services we are implementing. But thanks of Kubernetes and OpenShift, and OpenShift at the end, it's just an implementation of Kubernetes. We've got that some of these microservices are implemented on the platform. For example, if you're using Kubernetes, we've got the discovery and invocation implemented thanks of the concept of Kubernetes service, and also we've got the elasticity microservice feature implemented because you just need to do kubectl scale, and Kubernetes will take care of a scaling up and a scaling down, or even you can implement or use automatic scale ups and scale downs. If you're a part of Kubernetes, you're also using OpenShift. Monitoring, logging, and pipeline are also fixed. But notice that there are still some missing pieces here: resiliency, authentication, tracing, for example, or API. And this is exactly what is Istio. I don't want to, go deep to explain what is Istio, because a lot of previous sessions from today has been explained it, and they did it really, really well. But I just want to tell you that thanks of Istio, most of the microservices are implemented. Notice that there is some overlapping, for example, in the discovery, but thanks to Istio, we've got the resiliency, the authentication, the monitoring, and the tracing also covered. So before Istio, we've got all these microservices implemented inside my business code, inside my service. After Istio, we are putting all these capabilities inside a sidecar container. So now we've got a pod. And remember that the pod can contain more than one container. And with Istio, what we are doing is creating a sidecar container, implementing all these capabilities inside this container. So an Istio application, or an application that is using Istio, it contains a pod with two containers. My business logic, the business logic that I'm implementing, that the service is implementing, and a sidecar container that are implementing all these capabilities. And what's happening after that is that all the network traffic, all the communications goes through the sidecar container. So when I want to make a request from service A to service V, I'm not sending the request directly to the service V. What I'm doing as a service A is making a request to the sidecar container, my sidecar container. Then the sidecar container takes the request and send it to the sidecar container of service V. This sidecar container of service V, it just makes the request to the real service V. And then, of course, this, make more calls and more calls and more calls. And then the response from service B goes to the sidecar container of service V, which at the same time, as you might guess, it sends the response to sidecar container of service A. And finally, the response goes to the real service A. So notice that now all these cross-cutting, all these capabilities, cross-cutting concerns, microservices are all of them implemented inside the sidecar container. And since all the traffic is intercepted by these sidecar containers, I can start manipulating it. And if you are curious about what this sidecar container contains, I will tell you that it contains an envoy proxy. So thanks of Istio service mesh, which is code independent, it means that if you are using Java, you do not need to learn any libraries for implementing resiliency or metrics or monitoring. If you're into the JavaScript, you do not need to learn any new library, nothing, because it's code independent. You can start doing intelligent routing and load balancing, for example, kernel releases or their launches. You can implement chaos engineering by applying fault injection. You can apply resiliency, circuit breakers, bulk ahead patterns, retries. All this stuff is also implemented inside Istio. Observability and telemetry, metrics and tracing, exactly the same thing. Since all the traffic is intercepted, Istio has all the metrics and all the tracing information about communications and can provide this data. And what we are going to focus today is about security, encryption, and authorization. Thanks of Istio, we can make our microservices architecture more secure. So, as I said before, this is the link where you will find all the things that I'm going to show you today. Let's start with security, and these are the topics that we're going to cover: egress blocking, MTLS, and encryption, access control, JWT. Remember that, JSON Web Tokens, but it's not called GWT. I know that, sometimes people say JWT, but it must be named JWT. Okay, so I'm going to, when I refer to JWT, it's GWT token, right? JSON Web Token. And also, we're going to see how to do airbag authorization. So, most of the communication in our microservices architecture are inbound and internal. Usually, we do not have access to external services. For example, when I said external services are services that are out of our control, it's out of our company. So what you can make with egress is blocking any traffic that goes outside our architecture, outside our service mesh. The reason for that is that, well, at the end, you do not want that anyone can use our nodes to do by Bitcoin mining, right? So we want to avoid external access and just permit the traffic and a specific traffic in a specific port in a specific host goes outside our mesh. This is egress blocking. Also, one of the important things about microservices architecture and the internal traffic is that we might think that it's not necessary to encrypt traffic between our internal services. So if I got my service customer, my service preference, and my service recommendation, it's like, okay, it's internal, it's in my backbone, it's my cluster, it's fine to use HTTP. Because at the end, it's really hard to use HTTPS, right? Because you need to configure the certificates, the certificates authority. I need to go to my customer code and change it, and deal with the certificates. And yeah, it's really painful, right? So since it's my cluster, I'm going to use HTTP, and that's fine until someone finds a way to do an eavesdropper plot, which basically start sniffing your traffic and sending that traffic to another place. Then, okay, you've got a problem because your traffic is not encrypted. So this is exactly what we want to avoid, that if we've got a pod that is sniffing our traffic cannot be watched in plain text. Another thing, access control. With Istio, we can access the control of who can call who. For example, if I got customer, preference, and recommendation, with Istio, I can limit that only the requests that are valid are from customer to preference and from preference to recommendation, but no other control. So you cannot make a request from customer to recommendation, no access or no request from recommendation to preference. And that's really important. And it's really important because notice that if, for example, an attacker gets access to customer and an attacker knows that there is this recommendation where there is some kind of interesting information, since it's inside customer, if you do not make any access control, he will be able to make requests directly from customer to recommendation by passing preference. But if you set these access control rules, then Istio will protect you against this kind of attacks. Of course, you can even provide that there is no external access to, to any of these spots. So preference cannot be accessed from outside. And the final one is your JSON Web Token issuer. When you are into the microservices architecture, you want to authenticate calls between services. Probably you're using a JOT token, right? You've got a token, and then you are sending this token in the authentication header, like a bearer token, and you send it to the other service, the service you're calling, and then these other services are going to validate the token, said that it has not been modified, that it contains the rules or the groups that can only access to that service, and so on, that the token has not been expired, all these kind of rules. And then when all these rules has been passed, they are correct, then you know that this request is valid, and you can make your logic, right? Run your logic. And this is something that usually you implement on your source code. But again, this is hard to maintain. You need to provide a public key to verify the signatures, or the signature of the token. You need to parse the token. You need to validate that it has not been expired, that the issuer is the current one, and so on. So there is some things that you need to maintain, right? And okay, Istio can help you on this as well. And that's all. Well, I'm joking. Okay, now it comes the funny part, which is the demo. But I'm going to show you how to implement this on Istio. So let me go here to my my cluster. Notice that I've got, as I said before, customer preference, and now I've got recommendation V1, recommendation V2, and recommendation V3, and I've configured a virtual service to make that all the requests goes from customer preference and then V3. So you can do a curl, and notice I'm going from customer preference recommendation, and see here, this is the time, but this time is not coming from my node machine. It's coming from here. It's coming from a REST API called wall clock API, which basically is a JSON file. Well, it's a JSON REST service that returns a current time. So now notice that I can get access outside, because by default with Istio, at least in the version that I'm using of Istio, right, any outbound traffic is permitted. So any traffic can go outside the mesh. To fix this, you need to run the next command. I mean that if when you install Istio, you can change that, but in this case, I always install it as allow any, and now I'm just changing, I'm replacing this configuration value. I'm saying that instead of allow any, so instead of saying I want to allow any outbound traffic, I am changing to registry only. Now what's happening when I do a curl? Well, it takes a bit of time, right? But no worries. It's going to work. Let's wait a few seconds or a few more seconds. Come on. It usually takes like 1 minute or so, because it needs to update the configuration of all the all the Istio components. And in this case, I think that it's like 3 nodes, 3 worker nodes. So yeah, it might take, and it's in South Carolina. I mean, it's far away from where I am, so it can take a bit, but it will. There it is. Notice that now, when I'm trying to access the service, now I'm getting an error, an internal server error saying, hey, you're trying to access wall clock API, which is this one, but I don't allow you to make requests outside the mesh. So what you need to do now? Well, you need to create an egress rule saying, hey, I let you go through wall clock API. So I can do kubectl apply, -f, Istio files, service entry, wall clock API. And now notice that when I do curl, it works. Of course, if I do kubectl delete, -f, Istio files, service entry egress, and now I do curl, it fails. Why? Because when I've done the apply, I'm applying a rule for allowing this traffic. So if I do a cat of this file, see that I'm saying, hey, there is a new service entry that is coming from Istio, which is here it's a metadata with Egress Rule. I'm saying the host is wall clock API, the port is the 80, the protocol is HTTP. So any service that is trying to reach wall clock API on port 80 using HTTP, the traffic is allowed to do. It's allowed to make the request. If not, then abort the communication. And this is exactly why it's not working on the other when I delete the this egress rule. Delete. Okay, well, it doesn't. Okay, now, of course, if I do curl again, it's not working. Okay, this is for the egress rule. So first advice, always make your, always block outbound traffic and create the egress rules. This makes your application safer, so anyone can go out of your mesh without permissions. So now let me let me clean all the rules that I've got. Notice I'm just cleaning this is a script that I've got to remove all the Istio configuration, so we get it a clean I would say a clean Istio configuration. Let me do a git deployments, and let me delete this deployment because I don't need it anymore. Okay. Now, if I do get pods, see that always, as I said before, my pods contains two containers: my business code and the Istio container. In fact, I can do the scribe. Oops, I think I've done something wrong. Scribe, because this is pod. And you see that there are two containers here. Let me see here. Notice that here is containers. There is a recommendation container that it's my business code, and then here there is an Istio proxy container, which of course it's an Istio. It's a proxy container. It's Envoy proxy. Okay, now if I do curl again, see that I'm getting customer preference recommendation v1, customer preference recommendation v2. Okay, now let's start blocking, right? How the access control of these services. Basically, I want to implement this. So I only want to make available communication between customer to preference and preference to recommendation, and not any other communication. So let me do kivctl. Kivctl apply. Oops. Use F Istio files. Access control. Oops. Wait. No, it's authorization. Sorry. No, authorization policy deny all. So basically, now I'm saying no communication between services is permitted. So now when I do a call, wait, I'm get an airbag access denied. Okay, it say no, you cannot access anything. But what's happening if I do this? So I'm going to say, well, not all the traffic. I permit you the traffic to customer. Now I'm getting customer, but then I've got the airbag because I cannot access preference. If now I apply the same thing but with preference, then it says is customer preference. Okay, it's behaving strange, this thing today. Yeah, now it's customer, then it's preference, and then it says airbag denied because it's the recommendation, but that's failing now. Finally, I can apply this, and now, of course, it's going to work all the time. And if you want to see how this file looks like, I can do a cat. And see that I'm saying that recommend that if the source comes from the preference service account, and preference service account is the service account tied to preference service, and the operation is get, then do not block it. In any other case, then block it. For this reason, now with curl, it works. And even I can show you that I'm not saying you something that is not true. I can go to recommendation, recommendation pod. I'm going to go inside. Okay. Now I'm inside the pod, and if I do a call localhost, no, recommend preference 8080. Of course, I'm getting an access denied because remember that I said that the communication can only go from customer to preference and preference to recommendation. And now I'm trying to go from recommendation to preference. And this is forbidden. So I'm getting an airbag access denied. Okay, so this is the second rule that you need to learn from Istio security. First one, remember, it was like the egress, so block all traffic outside, all the communication outside your mesh. The second one is that make clear rules on which services can call which ones, right? So if customer can only call preference, then make a rule for it and forbid any other communication. Then let's go to the next example. The next example is about MPLS. By default, and this is a secret, by default, Istio enables MPLS in the communication between services. So now, when I was doing this, customer and preference, the communication between the services are done with HTTPS. But, and here is the key point, customer and preference services, my business logic, has no clue that it's in HTTPS, because from the point of view of customer is doing a request using HTTPS, and this request using HTTPS, okay, it's done because nothing is configured, but the Istio proxy takes this HTTP request and converts it to HTTPS and sends the request from service A to service B, from customer to preference using HTTPS. Okay, now let me show you one thing. Let me first of all disable MPLS so you can see that what I'm saying is true. I'm going to disable MPLS. Okay, now if I do this call, which is IstioCTL experimental blah 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 blah, okay, then here you will see, but basically you should not see that I'm checking the auth says, okay, the auth is to check all the authorization things. For the customer service, says that there is no MPLS. So MPLS is disabled now. It means that communication between customer and preference is done using HTTP. Now, let me run the next code. Basically, I'm going to use ksniff to sniff traffic. Okay, this is not the pod. Okay, the pods. Kiev Carol sniff. Okay, I think that is this one, and I'm going to save it in capture one pickup. Okay, now I'm just running ksniff to sniff all the traffic between customer and preference. Okay, now I'm sniffing the traffic and I'm doing the call. Of course, nothing happened, apparently, because everything worked. But remember that I am sniffing, I am capturing the traffic between customer and preference. And any attacker could do that. I'm just doing it, just with this command. Now, I'm going to Wireshark. I'm going to open the pcap number one. And remember that I said that it was not encrypted. And let me check over here. Where is? Not here. Here, this frame, this one, okay, it says that I sent a GET using HTTP to this destination, and here you can see the content. Okay, if I go over here, where is the content? Here, preference, blah 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 blah, and then here is the plane, and here you see that this preference recommendation v2 blah 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 blah, right? So the content is there. Anyone can access. So you should always enable MPLS. By default, it is, but as I show you how to change that by using IstioCTL experiment and check it. If not, if it's disabled, then what you can do is this. You can enable by using this file that I can show you right now. Notice that I'm just saying that my namespace tutorial, I want to use MTLS in mode permissive. Now, if I run it again, this experimental out, you see that auth rules for port 8080, it's impermissive. That it's exactly what we want. Now, if I do a curl, I could sniff it as well, but I'm going to skip it now because if not, we're going to run it out of time. But, oh, well, we can do it. Let's try it. Now, I can just sniff. I can sniff again the traffic. Now remember that I'm with MTLS. I'm going to put it in capture 2. So I'm storing in another file. Now I'm just starting sniffing the traffic. I just send the call. I stop it, the process. I'm going to Wireshark. I close it. Okay, here it is. Going to open, pick up 2, run it. And now notice that traffic of HTTPS is never captured by default by ksniff. And because of that, there is no traces, no frames regarding the communication, the content, the preference recommendation. Okay, so if you want to enable MTLS, you know how to do it with this YAML file. And if you want to inspect if the traffic is encrypted or not, you can just use ksniff and then sniff the traffic, put it inside Wireshark and inspect all the traces. Then, if you're wondering how ksniff works, basically you need to set here the Istio proxy because it's the traffic that we want to sniff, and here is the IP of the container we want to sniff the traffic. Now, we are almost at the end. Let me clean everything. And let's go to the authentication and authorization. One of the things that we need to do with microservices is authenticate and authorize services using JSON Web Token, right? So we want to send a token from service A to service B and validate that this token has not been modified, has not been changed, it's not expired, and so on. This logic usually it's on service side, so you put it on your business logic, on your container. But with Istio, we can leverage this to the Istio proxy. So Istio proxy is the one who's going to validate the JSON Web Token and so on. So I'm going to enable authentication job. I can do a cat of this and see that I'm just saying that, yeah, there is an issue. This is this one, and this is the public key to validate that the signature has not been modified and so on. Okay, now I can do a call and it works. But what's happened if I send, and this is going to be, wait, here, notice that says GJOT verification fails. The reason is that this token is an invalid token, is an expired token. Okay, if you decode this token, you'll see that it's expired. So what I need to do is get a valid token, which is here. If I do an echo of this, okay, of course, this is another token, and this token is valid, has not been expired, has not been modified, the signature validates, the issue is correct, and so on. And then, of course, if I do a curl of, this token, now it works because the token is valid. But here, I'm just saying that I want to provide a token that is valid. I'm not doing a reback at all. I'm not doing a role-based access control. What's happening if I want to do a role-based access control? Yes, you can do it. Notice I'm going to apply this YAML file. I'm going to do a cat. And now I'm saying that I only allow traffic to reach customer if the request principal is this one, and well, when the source, yeah, is this one, okay, and the role, the claim role of the token contains the value customer. Now, if I do exactly the same thing, it fails. Yeah, wait. No, it fails. Yeah, it's this update refresh time, right? It fails because the token, this token, okay, does not have a claim with name role of type customer. But if I do this and I create the token, a valid token, this token contains the role, and I do a curl, now it works all the time because this token contains a claim of type customer. So as you've seen with Istio, without redeploying anything, I mean, notice that my services are always the same, that were deployed 10 hours ago, 9 hours ago. I am improving the authentication and authorization between services. So thanks of Istio, your application do not need to deal with outside rules, so network traffic going outside the mesh. You can block unwanted access between services, right? All the traffic between services are with MTLS, so your services do not need to deal with certificates, authorities, nothing. Everything is managed by Istio. And finally, the authentication and authorization between Istio services is also managed by Istio. So your code does not need to implement any JSON Web Token logic. And that's all. We'll still have 1 minute that we can take it for questions. And remember that, as I said before, that if you've got any other question, my Twitter at Soto, my email at soto@redhat.com, and what it's even more important to replay all the things that I've done today, the end.dev/Istio tutorial. Thank you very much.